So we're going to start adding and subtracting rational expressions. In order to add and subtract rational expressions, you're adding and subtracting fractions, which means that you're going to have to find a common denominator. And what the common denominator basically is the least common multiple of the denominator. So we're going to discuss finding the least common multiples of expressions. So one way to look at it, look at the coefficients. If you have all monomials, you're looking at the coefficients and finding the least common multiple of them. And what this one has is a 3 times 2 to be 6. The 15 is 5 times 3. And the 9 is 3 times 3. So the least common multiple, because this one has 2 3's, the least common multiple has to have 2 3's. This one has a 3. We'll already have that included in that least common multiple. I'm also going to need this 5 in there. And this one has the 3. I already have that there, but I need to include that 2. So the least common multiple is going to be 3 times 3 times 5 times 2, which is going to become 90. And then I'm looking at the x's. So if I have x, x squared, and x, the highest exponent is x squared, so I have to include that in my least common multiple, and the y is going to be y to the 4th. So this is going to be the least common multiple of those 3 monomials. When you're given expressions, quadratics, trinomials, binomials, you're going to have to factor them to find the least common multiple. So when I go and factor this, I'm going to factor out a y squared. I'm left with y squared plus 8y plus 15. And when I factor that, I get y plus 5 times y plus 3. And still got that y squared out in front. When I go and factor this one, I get y plus 5 times y minus 8. So I'm finding the least common multiple between these two. A lot of times what I will do is I'll start with one of them, the larger one. It has to have everything in here. So I do y squared. It's got to have the y squared. It's got to have y plus 5. It's got to have y plus 3. And when I go to the next one, it's got to include everything from this one as well. But I already have this y plus 5 included in my least common multiple, so I don't need to include it again. The only time I would need to include it again is if this was like squared. Then I would need another one. But because it's not, it's already included. I already have one in there, but I don't have this y minus 8. So I'm going to include that y minus 8. And that would be my least common multiple. So now that I'm actually going to add and subtract, I'm doing the same thing but for the denominator. So I need to find the least common denominator here from 2x cubed and 8x y to the second. So I'm looking at 2 and 8, and the least common denominator there is going to be 8. I need an x to the third, and I also need y squared. Okay, this one has an x to the third. This one has a y squared. I got to have the highest of every variable, basically, is what I need. And in order to combine these, I need to have the common denominator. So what I'm going to do is multiply both numerator and denominator by something in order to make it this least common denominator. So to get the 2 to become an 8, I need to multiply by 4. The x cubed is already there, but I do need this y squared. So I'm multiplying numerator and denominator by 4y squared here. And over here, I already have the 8. I already have the y squared. All I need is x cubed. Well, I already have one x. I just need to multiply that by x squared. And so this becomes 12y squared over 8x cubed y squared plus 5x squared z over 8x cubed y squared. And now I can combine those together. Well, since they don't actually combine, I'm just going to leave them separated. And I get 12y plus 5x squared z over 8x cubed y squared, and just leave it like that. If these two would be able to combine or simplify, then you simplify it. To state any restrictions, we're stating what the variables cannot be. And because you have an x in the denominator and y is in the denominator, that means x cannot equal 0 and y cannot equal 0 as well, because you're not allowed to have a 0 in the denominator. So for this next one, I have my denominators as expressions and a binomial and a trinomial. So to find the least common denominator, I'm going to have to factor each of them. So I have 6 that can factor out of this first one, and I get x minus 3. And the second one, I have a 2 that can factor out. And then it factors into 2x minus 1 times x minus 3. So we're getting back into the factoring quite a bit, and that's going to be very important. So to find my least common denominator, I'm going to find the least common denominator between 6 and 2, which is going to be 6. I have this x minus 3, and then 2x minus 1. I don't need this x minus 3 because it's already in there. So I started with this one, and then I had to include this 2x minus 1 because it was in this denominator as well. So here is my original just factored. I factored the denominator here, factored the denominator here, and I need to get this to become my least common denominator, so I need to multiply by 2x minus 1. Once I multiply by 2x minus 1, this is going to be equal to that LCD, but I got to do the same thing to the numerator. What I need to multiply by here, well, the x minus 3 and 2x minus 1 is already in this one. I just need this 2 to become a 6, so I'm only multiplying by 3 here. And to simplify, I'm going to leave the denominators factored. I just multiplied the 3 with the 2 to become 6. That was it. Remember, I had to distribute this, and I had to distribute this one. Okay? I haven't done anything with this minus. Remember, the only difference with minus is that it's subtracting this whole thing. So a lot of times what I'll do, I'll change it to a plus and change all the signs from this numerator, and now I can combine my like terms. So it's going to be 10x and negative 3x becomes 7x, negative 5, positive 3 becomes negative 2. It's still over the denominator because I'm just adding and subtracting. The denominator stays the same. This is my simplified form. The restrictions come from the x values in the denominator. It's basically coming from each parentheses. What would make this parentheses a 0 is if x is equal to 3. So that means that x cannot equal 3. And x cannot equal 1 over 2. The reason I get 1 over 2 is because 2x minus 1 cannot equal 0. Well, that means if I basically solve it, that means that x cannot equal 1 over 2, or 1/2. So I have x cannot equal 3 or 1/2. So this is the last type, and although it looks really difficult, it's not as difficult as it looks, okay? These are complex fractions. Basically, anytime you have a complex fraction, it's going to be a little bit easier to write it like this, okay? Because it's this numerator divided by this denominator. Okay, well, in order to divide them, I have to simplify this part and I have to add those. Well, my least common denominator here, this denominator is 1, this denominator is x, so is going to be x. I don't need to change this one. I do need to multiply this one by x and x, so that's going to be x over x, which is still 1, plus 1 over x. Divided by, and this one's going to become y over y minus x over y. Get the denominators the same. Now I can combine them to be one fraction. Well, x plus 1 over x divided by y minus x over y. And now remember, to divide, you're going to multiply by the reciprocal. So I have x plus 1 over x times y over y minus x. I can't cancel out the y's, I can't cancel out the x's because this is a binomial. So you just distribute this y into here, and I can't simplify that anymore.